Hello and welcome to my first GCSE video on acids. Today we have a very special guest in Stephen Finley.
Hello, I'm Stephen Finley.
Yeah.
I'm Mr. Bioton One's friends.
Firstly, because I do not have very good equipment, it might be hard to hear him because I've only got a headset microphone. Anyway, so acids and bases. Here is a list of acids. Stephen, what acids are these?
So you've got hydrochloric acid,
HCl,
sulfuric acid,
H2SO4,
phosphoric acid,
H3PO4,
nitric acid,
HNO3,
and carbonic acid.
Yep, H2CO3. And you also have antacids, which are the opposite, also known as bases. And these are, Stephen?
We've got calcium carbonate,
CaCO3,
magnesium carbonate,
MgCO3,
sodium hydrogen carbonate,
NaHCO3,
magnesium hydroxide,
MgOH2,
and aluminium hydroxide.
AlOH3. Other common bases include just sodium hydroxide and others like that. Now, the most fundamental reaction when it comes to acids is acid plus base becomes salt and water. Most reactions in acids end up forming salt and water or something similar. So, for example, you have HCl, hydrochloric acid, plus sodium hydroxide. And that becomes sodium chloride, which is, Stephen?
Salt.
Well done. Plus water. And in this we have the pH scale. Acids are acidic. They have a pH below 7 and above 0, though it can be to -1.
Oh, no.
Then you also have alkalines, which are bases, and that is 7 to 14. 7 is exactly neutral. Pure water is exactly neutral. Now, the difference between a base and alkali, alkalis are just soluble bases. Antacids are used in medicine to neutralise excess stomach acid. Stomach acid is always HCl, and if you get two more, it can be bad and painful. So you use antacids, which are such as calcium carbonate, magnesium carbonate, which will neutralise it. Now, in the pH scale, to tell pH, you can use indicators. Most common is universal indicator. And what this does is at each different pH, it'll have a different colour. At 0, it is red. At 7, it is green. And at 14, it is purple. You can also use litmus paper. Blue litmus paper will turn red in acidic conditions. Red litmus paper will turn blue in alkaline conditions. And here are some reactions you need to know about. We've had acid plus base becomes
salt and water.
Well done. And then you have acid plus metal oxide becomes salt and water as well. So, for example, we've got HCl plus copper oxide becomes copper chloride plus H2O. There's an example of balancing. If you look, on one side you have two HCl, so there's two hydrogens. On the other side you have H2O, two hydrogens. One copper, two chlorines, one oxygen. Now you have acid plus metal, not metally as I originally wrote. You have acid plus metal hydroxide becomes salt and water. So these are the calcium hydroxides, the magnesium is the one found in antacids. So for example here you have sulfuric acid plus calcium hydroxide becomes calcium sulfate plus 2H2O or water. And the final one is acid plus metal carbonate becomes salt, water and CO2, because I couldn't fit carbon dioxide on the paper. So you have, in this case, we have 2 nitric acids plus magnesium carbonate becomes magnesium nitrate plus H2O plus CO2. These are all examples of neutralization reactions. Electrolysis. Electrolysis is decomposing compound using electricity. Any compound which can be decomposed by electrolysis is called an electrolyte. Most common example is salt, which is sodium chloride. This can be electrolyzed. And chlorine and sodium is produced. Chlorine is an important product which is produced by the electrolysis of sodium chloride. It can have many uses, such as treat water supply and kill microorganisms, to manufacture bleach and other cleaning products, and is in the manufacture of plastics such as polychloroethene, PVC. Anyway, the test for chlorine is you have blue litmus paper and you hold it above chlorine. The gas will then turn it red, shows it's acidic, but any acid can do this. What is specific to chlorine is that it will then turn white because it is a...
Bleach?
Yes, Stephen. Well done for saying that incredibly quietly. If you can't hear Stephen, that's probably a good thing. Right. Electrolysis of water. This produces hydrogen and oxygen. The test for hydrogen is the classic squeaky pop. You hold a lighted splint in the mouth of the test tube, and if it goes pop, you got hydrogen. Oxygen, if you have a glowing splint and then put it into oxygen, it will relight because oxygen makes things burn. Uses of hydrogen, you can use it as rocket fuel and in weather balloons because it will float, but not in airships, as we know from Stephen.
The Hindenburg.
Yes, because it caught on fire and everyone died. Uses of O2. Breathing, because we need oxygen to live. In hospitals, you'll have tanks of oxygen to help people live, which is always useful. And that is all on acids. Nice quick video. I hope you enjoy GCSE, and if there's any of my A-level students watching, there will be a proper video on A2 acids coming. They're coming your way. Thank you for watching. Goodbye.
See ya.
Lol.